Assalamu alaikum and good day to each and everyone. Well, basically, this is our third video for Math 221, which is the approximations and round of errors. Okay, so again, I highly encourage, or you are obliged to print the file that I have uploaded, and as well as you are highly encouraged to print that one while I am discussing this topic for you to easily cope up, or for you to easily follow to my lecture. Okay, so at this moment, what I will be discussing is about approximations and round of errors. So let's start. um, as you can see in engineering or in mathematical calculation, there includes, or we cannot fully say that the arrived answer is all true or all correct, or let's say walang error. Because for example, yung sa lecture 1 natin, if you can still remember the falling parachutist, we have solved, or we have analyzed the behavior or the falling parachutist by numerical methods in lecture 1, and then sa lecture 2 we have discussed it, or we have solved it using analytical method. As you can see, or as you can if you are to check, there is this a bit, or may maliit na discrepancy doon sa solution natin, or yun yung sinasabing error, because I mean, there is this discrepancy dahil sa pag-round off natin sa numbers. Pero hindi natin sinasabi na mali yung solution. It's just that sa final answer is may konting pagkakaiba because of the solution, or because of the way that we have solved the problem. Kasi sa lecture 1, we have solved pure calculation that involves rounding off of numbers, right? Pero sa analytical method, maliit lang yung, we did not really round off numbers because it is in analytical. We have programmed it in Microsoft Excel. So yung pagkakaiba or difference in solution or difference in final answer sa lecture 1 at saka lecture 2, yun yung sinasabi nating discrepancy. Okay? And just a heads up, sa engineering field, whenever we are solving problems, hindi natin masasabi na yung na-derive or na-arrive natin na answer is yun mismo yung answer, or yung exact answer. Because every time that we are doing rounding offs, or every time that nag-approximate or nag-round off tayo ng number, there involves this change in number or change in final answer. So, maaari, if we are to solve a certain problem, pwedeng say student A is iba yung final answer na na-arrives kay student B. For example, yung answer ni student A is 13.56. Si student B, pwedeng 13.5678, so on and so forth. But it doesn't mean na yung isa is mali, tapos yung isa is tama. It's just that their method, or their way of rounding off numbers is, is makaiba, okay? So sometimes it has something to do with number of decimal places kung bakit nagkakaroon ng rounding off errors or approximations error. Okay? So, now, let's proceed with significant figures. Remember, in significant figures, as you can see, significant figures, this lecture deals extensively with approximations connected with the manipulation of numbers. So sa lecture na ito, ang pag-usapan natin dito is on how to approximate numbers. That is, we need to manipulate numbers, but with scientific basis. Okay. Consequently, before discussing the errors associated with numerical methods, it is useful to review basic concepts related to approximate representation of the numbers themselves. So, for which to consider significant figures, as you can see in here, the speedometer, this one is the speedometer, yung mga labels dito, speedometer tawag yun, tapos this one is the odometer. So as you can see sa speedometer, as you can see in the speedometer, we can simply say that by visual inspection, masasabi natin na sa speedometer, it trades between 48 and 49, right? But then, by visual, visual means of pagtingin sa speedometer, we can assume, or we can simply say na yung speedometer reads between 48 and 49. But then since it's between, we can also say that it's approximately, for example, 48.8, or someone might say it's 48.9. It is safe to say that we are traveling 48 or 49. Okay? But then in mathematical computation, the larger, sarami ng decimal places is ganun din accurate yung solution natin. Again, sa calculation, sa mathematical solution, sa dami ng decimal places is ganun din ka-accurate yung solution natin. For example, nag-solve tayo ng problem involving this speedometer, tapos sabihin natin na yung speed ng car or yung speed ng isang vehicle is 49. Kung sabihin natin 49, hindi naman malayo, pero hindi siya katotohanan sa readings ng speedometer natin, since hindi naman siya umabot ng 49 kilometers per hour. Pero we cannot also say that it is traveling, for example, with 48.8642138 due to the limitation of the speedometer. So sometimes it is safe to say na the car still, due to its limitation, safe pa rin na sasabihin natin na this car or this vehicle is traveling with the speed of, or with the velocity of 49 kilometers per hour. And considering its odometer, this is the odometer, the car has traveled 87,324.5 kilometers. Okay, so this one speeds the distance, and this one, the speedometer speedometer measures the velocity of the vehicle being considered. So in the formal definition, the significant digits of a number are those that can be used with confidence. Meaning to say sa confidence is magiging confidence yung number na ginagamit, because masabi natin na malapit siya sa totoong value, sa true value. So they correspond to the number of certain digits plus one estimated digit. So ibig sabihin, for example, sa readings na ito, ang significant figures daw, based sa definition na ito, sa libro na ito, ang significant figure daw is yung may assured or certain ka sa certain ka sa digits, meaning to say, for example, yung 48, di ba sure tayo na between 48 and 49. So sure tayo na 48 siya, right? 48 plus one digit, one estimated digit. So pwede sabihin na 48.8, 48.9, okay? So yun yung sinasabi na or is this significant figure sa libro, or significant digits sa number, sa libro na ito. So iba sa section na ito, for example, this one, for example, in speedometers, for example, the speedometer and the odometer in figure 1 yield readings of 3 and 7 significant figures respectively. For the speedometer, the two certain readings or the two certain digits, ang two digits daw na sure tayo is yung 48. Okay? It is conventional to set the estimated digit at 1/2 of the smallest scale division on the measurement device. Thus, the speedometer reading would consist of the three significant figures 48.5. So ibig sabihin nito is, di ba, we are sure na the speedometer reads between 48 to 49. So let's say 48, okay? So that is the two certain digits. And then since what's this? Tapos conventional daw, or it's better to estimate the approximation or the significant digit by dividing this division into half. So we will arrive into a reading of 48.5. So let's consider the concept of significant figures, which has two important implications for our study of numerical methods. As introduced in the falling body problem or falling parachutist problem, numerical methods yield approximate results. Okay? Remember, numerical method, yung sa lecture 1 natin, yields approximate results. We must therefore develop criteria to specify how confident we are in our approximate result. One way to do this is in terms of significant figures. For example, we might decide that our approximation is acceptable if it is correct for significant figures. Ibig sabihin nito, for digit numbers, okay? So Number 2, although quantities such as pi, base e, or square root of 7 represent specific quantities, they cannot be expressed by a limited number of digits. For example, this one, pi is equal to 3.14, so on and so forth, and ito and so on. Because computers retain only a finite number of significant figures, such numbers can never be represented exactly. The omission of the remaining significant figures is called round of errors. So example daw, yung pi, yung e, di ba yung value niya is mahaba. So we cannot easily include all the numbers during our calculation. Sabihin natin na, di ba yung area ng circle is pi over 4 d squared, right? So hindi natin sasabihin na yung pi doon is input natin yung lahat ng calculation, lahat ng values ng pi. So to make it easier, or for the omission of the remaining significant figures, yun yung sinasabi natin na round off error. Usually ginagamit natin sa value na pi is 3.14, right? 3.14. But I hope everyone knows how to round off numbers. Okay? So both round off error and the use of significant figures to express our confidence in the numerical result will be explored in detail in subsequent sections. In addition, the concept of significant figures will have relevance to our definition of accuracy and in the next section. So, yung discuss natin dito na approximation and round off errors ay gagamitin din natin sa accuracy and precision for our next video. Okay? So that is all for the first video of lecture 3.